Can you hear me, Ashwin?
Yes, I can hear you.
Okay. Why are you sad today?
I'm fine. Why?
Okay. So actually, the life is still in front of you. You don't need to have any reason for being sad or or even worried.
Yeah.
Okay. So let me just share with you a few things because
Okay.
I still feel that maybe I didn't give you an optimistic view of actually automation in general. So automation,
Hmm.
although yes, I worked on a specific field which is machines, okay, where you have to deal with people on electrical side and also mechanical side. But uh, I
Yeah.
also I also dealt with other fields of automation. So now the technologies, because it's advancing a lot, so you find automation dealing with robotics, machinery. This is one thing, and also you find that they are dealing with things like this. So they call so this is a kind of automation. You're dealing with sensors, you're dealing with output devices, and the microprocessor is in between. So you find this in cars. So that is a high level of automation. Okay, so this is a different field of
Yeah.
automation. So I think you are aware now that there is a smart sensors and sometimes car are able to drive its own, so it's self-driving. It means that
Yeah.
and also if it is not even self-driving, they have some kind of protections in advanced cars now that so
Yeah.
this is a kind of sensor where it can actually detect if there is an object or obstacle that is nearby the car that is moving at the moment. So what it does, if there is an object or a car that is nearby, so it actually sends a signal to um, so it have a sensor. This is a sensor, okay, and this sensor actually send a signal, and this signal is translated into digital format because anything that is. Did you study anything about electronics or electricity in general?
Yeah, of course.
So
You
did you
have
study
some.
anything about sensors and voltages? Like,
Yeah.
okay, so in short, this is a sensor that produce some kind of electrical signal. This electrical signal,
Yeah.
the processor, this is a processor of a computer, a mini computer, okay? So this is what we call an embedded system. So this is a chip that is representing a processor, and the processor does not understand anything about electrical signal. So the sensor produce some kind of electrical signal. This electrical signal need to be translated to uh, a digital format, which is ones and zero that the processor can understand. So we use something called ADC. This is analog to digital converter. So it takes something from the real world and it translated to the world where the processor can really understand. So it only understand here, the processor only understand ones and zeros like that. So we need a translator. So same like if you have a Japanese person that doesn't understand any English, so you need a translator for that. You need um, somebody to translate from English to Japanese for you. So this ADC works for this way. It takes anything from the outside world and it translated to the world where only ones and zero can be understood. So when the signal goes to the processor, so it check just some if else statements inside. Of course, this is the simplest form of it. So it will check, okay, the nearest or acceptable value for a nearby car is what? Is it maybe 100? Maybe it's 200.
Mm.
So it will check that. So if it find that is it within the safe zone, so nothing will be done. But if it is maybe
Mm.
10, and 10 is dangerous, 10 is too close for our car to be. So the processor will send a signal that we need to control the brake. We need to press the brake according to our current speed. So we will consider our current speed. We will consider that what kind of pressure we need to apply to the brake to be able to actually reduce the speed to a certain limit to actually be far away from the obstacle, or even protect our car from any possible accident. So we don't press 100% unless the situation really dictates that. So here, this is not human. So this is accurate signal that we are going to give to the brake. So again, processor only understand ones and zeros. So we have to translate the instruction from the microprocessor to something that can be understood from the outside world, which is the brake. So the brake needs some kind of action that need to be taken by it. So to translate, the brake, how to say, so this brake, it's like small bits like that. So this is the metal part, the metal circle here. So it's like that, and this is the pads of the brake. So we need to press the pads here to actually clamp, to do some kind of clamping on the brake. So when we do that, it will reduce the speed. But again, we are not just pressing on and off. It's either in or out. No, we are able to control the amount of brake or that we are pressing. So it means that we need some control of that. So in short, we take the ones and zero, or the values that we need to press the brake with, and this DAC, digital to analog. So this DAC actually controls that digital to analog converter. So it take our digital values from the microprocessor and it translates it back to a real world action. Okay, so and then that press the beds like this. So this can be a signal to a small motor, and that small motor might be the one who really press these beds toward the metal part inside the wheel, and then it breaks. It starts to break, and then we are able again using that sensor to detect. So once we apply this motor that push the bed towards the brake, then our sensor also will start to measure different values. Because why? You apply the brake, the car breaks down, it will slow the speed. So definitely the distance between our car and other cars or obstacles will start to become different. So maybe we will become far away from them already. So we will see, oh, is it? We will take a measurement again and we will check. So when we check, we will compare to the safest values that we have programmed inside. Are we still safe? Are the current output making us in a better position, or we need to apply more brake? So that is what we call a control loop. So this is something that actually, how to say, this is part of what you can do in the automation. So not all the automation is only machines and robotics. This is also part of what you can study in automation. You study sensors, you study output things that you can control. So and this is one of the possible things that you can actually do. Another thing, and you have to understand that many processors actually is part of embedded systems, which is part of a car. Car is a big consumer of microprocessors. There is a lot of microprocessors inside cars. And you also, I think you heard before about the ABS.
Yeah.
Okay. Do you know what the ABS do? Did you drive a car? Oh, you didn't drive a car before, right? You still
No,
drive.
I have a license. Yeah, I drive.
Okay. So do you know what is an ABS?
Yeah, ABS is the auto braking system.
Okay. So do you know what it prevents?
The anti-lock.
Yes, it's anti-lock. So
yeah, it stops you from locking when if you brake.
So
I don't know how to explain. Like, yeah, brake so hard, then you lock up the brakes.
Okay. So without this anti-lock, the car will actually so normally with the ABS, suppose you don't slip on the road, and not only that. So typically, when you brake using the old system where we don't have ABS, the car will, when you brake, it will tend to take not to move straight, but it will start to take angles like that. So it will move this direction. Okay, and previously in the old cars, like 25 years or 20, 25 years ago, with the old cars, sometimes the car will rotate around itself. It will totally rotate around itself like that. So that is not healthy, and it's not good and not safe for the driver. So what we say here, that the one controls the ABS is also a dedicated microprocessor, dedicated only for that. It will check, there is a sensor on every wheel that rotates, and this sensor measures the amount of rotation, and he by measuring the amount of rotation, he knows the speed of this spinning of the wheel. For each wheel, they calculate that separately, and then he compares the 4 wheels. In order for the car to remain moving straight forward when you are braking, he need to make sure that the 4 wheels are actually moving or braking, or no, not braking, moving with the same spinning. So the same amount of rotation is actually applies to the 4 wheels. So if this wheel rotates maybe 100 rotation per second, for example, just for example, so all the other 3 wheels, okay, need to actually have the same amount of rotation per second. If they become different, then the car will start to deviate from the normal straightforward road. Okay, so it will, if it is too much, it will drift, and then it will start rotating around itself. Okay, and that you can see in the old movies. When the old cars used to brake, they will rotate around itself. Okay, so because again, it was not controlled. But now with the ABS, they prevent that. So it means that you brake very hard, and then the microprocessor will start to see. So is it all the wheels braking with this or moving with this 100 rotation per second, or no? If one of them is less, he will start to regulate that and pass the information between all the other wheels. So all of them must be braking with the same amount. So it means that if one of the brakes is braking too hard, he will reduce that amount of braking. So you yourself cannot control that. I mean, when you are pressing, you cannot control that. You are just pressing, and you expect all of the wheels to brake at with the same pressure. But in reality, this is not the case. Maybe there is an oil on the road. Maybe there is a water on the road, or so the wheels will behave differently. Okay.
Yeah.
Am I clear?
Yeah.
Okay. So again, here you find ADC, which is analog to digital converter that will translate the sensor reading into the microprocessor, and you will also find DAC, which take the result from the microprocessor to the outside world to take an action on the brake. So this is all possible ways that you can deal with cars and embedded systems. So this is part of the automation. So it's not, slightly you need to deal with some electronics and some mechanical parts, but not as bad when you are dealing with machinery only. Okay, and typically this is a high-end job. Actually, you earn a lot of money by working in this kind of fields. So I'm just sharing with you what is all the possibilities. Okay, now tell me, was the homework difficult?
No, it was okay. I was able to do it.
Okay, but did you notice that the homework got nothing to be done?
What do you mean?
Okay, you open the homework. If you open the homework itself, actually, I provided you with what is required in text.
Yeah. Oh, yeah.
But the code actually was there. I mean, so but the only thing that I wanted you to do is to actually tell me if you really understand the code. But actually, the solution is provided to you. So So are you able to tell me what did you understand so far from this exercise?
Yeah. Can I quickly go to the toilet?
Yeah, sure.
Okay.